Past Summit Preview. We're excited you could join us today for Grant Fritchey's session, Query Performance Tuning in SQL Server 2014. This 24 Hours of Past event consists of 24 consecutive live webcasts. Sessions will be recorded and posted online soon after the event. My name is Andrea Allred. Come find me at Past Summit in a princess dress. I have a few quick introduction slides before I hand the reins over to Grant. He will speak for 40 to 45 minutes, and then we'll move on to the Q&A, where you can ask any questions you may have. Next slide. If you're having any issues, type your issue into the question pane and someone will assist you. To maximize your screen, use the Zoom button located on the top of the presentation window. Feel free to enter your questions in the Q&A field at any time. The questions pane is located on the right side of your screen. Once we get to the Q&A portion of the session, I'll read off your questions to the speaker. Note that there will be a short evaluation at the end of the session. Your feedback is important to us, so please take a moment to complete it. It will show up on your screen. I'd like to take a moment to thank our event partners. The staging of 24 Hours of Past would not be possible without their support and dedication. They are the reason this event is available free of charge. Thank you to our presenting sponsors, Microsoft and Dell Software. Next, as you may all know, this 24 Hours of Past is a preview of Past Summit 2014, the largest conference for SQL Server and BI professionals. With over 5,000 attendees representing 2,000 companies from 52 countries, Summit is a time to share, connect, and learn with your peers and industry partners. Past Summit is not only a week of intensive learning and knowledge sharing that will offer strategic insights, it's a time to network and rub shoulders with industry experts. Taking place in Seattle, Washington from November 4th through the 7th, Past Summit will feature over 190 world-class sessions across 5 topic tracks. These 24 Hours of Past sessions will provide a mere glimpse of what you can expect from Past Summit. Find out more at www.pastsummit.com, and if you register by September 26th using the discount code 24HOP14, you'll get $200 off the registration fee. And now, please allow me to present the speaker of the hour, Grant Fritchey.
All right, thanks, Andrea. Well, let's get started. Today's goal, really straightforward. I just want to give you guys a set of checks, a checklist, just a set of common, low-hanging fruit, easy-to-find stuff, things that you can immediately get in front of so that you have got your queries ready to go as much as possible without getting into full-blown query tuning. Now, my goals at Summit are much more involved. I want to talk to you about how the optimizer works. I want to get into massive reading of execution plans and go through a whole bunch of things around common problems inside of queries and how you identify them, how you resolve them, and just different methods for getting your queries to run faster. That's not today. That's at Summit. Today is that simple checklist. My name is Grant Fritchey. I am the Scary DBA. This is my contact information. Please use it. Get in touch. This is my blog. These are my email and Twitter. And you can get in touch with me directly if you have questions about anything that we go over or any other kinds of questions. I definitely want to talk to you. I respond to my email. One little point I would like to bring up, that we are raising money for Doctors Without Borders. And if we break $10,000, myself, Adam Mechanic, Brent Ozar, and Steve Jones will be wearing the little rainbow fuzzy things that you see pictured there on the right. So please donate. This is a worthy cause, and that way you can make us act silly at the Summit. Now let's get going. But before we really get going, I would like to point out one thing very important. I'm going to give you a lot of good information. It's been tested. It's been validated. I know that this stuff works, but your environment is different than mine. And it's extremely important that you take the time to test this information out. You really must be sure that you validated everything I'm going to say. You don't want to just simply trust the information I'm giving you. You want to validate it before you go on. So please test, 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 test. Think of it like the spam song, just substitute the word test, right? You can be sure of what you're doing if you test things. Now, this is focused on performance tuning. Performance tuning is the main point that we're going to go over, and I'm not getting into a lot of hardware tuning. I'm not going to get into a lot of system tuning, and it's just an important point is that this is performance tuning. Another thing to remember is that there are always going to be exceptions. Again, go back to testing. Validate what I'm telling you. Just because it works in one situation does not guarantee the same thing will work in a different situation. There are, there's different code, different structures, different mechanisms at play. You may also be dealing with very, very different hardware. If your hardware is, radically larger, that's going to have an effect. If your hardware is teeny tiny, that's also going to have an effect above and beyond any kind of T-SQL problems you may or may not have. I'm sure that I mentioned testing. I would like to reiterate, please validate everything I do with good testing practices. Do not trust me. Don't trust anyone, no matter how smart they are, no matter how capable they are. Your situation could be different. You need to test these things. Don't simply blindly put them into production. Also, when you start making changes, you need to make them in an incremental fashion. You want to make small changes. Fewer changes more frequently is better than a large number of changes on an infrequent basis, because you want to be able to do one thing and one thing only. You want to be able to monitor your servers so that you know what's going on them. It should not be a surprise to you how the behavior is affected by the things that you do. And if it is a surprise, you want that surprise caught as soon as possible. You don't want it to linger around. Now, as I said, I don't want to spend a lot of time on servers, but there's a few bits and pieces on server configuration that we do need to talk about. They are fundamental to query tuning, and I just want to kind of get some of that stuff out of the way. It is down to the basics, the same things that you're always going to run into, the memory, the CPU, and the disks. These are your fundamental problems. Yes, you may hit networking issues, but those are fairly rare. Most of the time your network is turned on and left alone. But memory is always a problem. CPU can be an issue, and certainly disks are a problem. So let's talk about just a few things that you can do to alleviate these things to make sure that this is not a driving factor for your performance issues. So, memory, talking right off the top. Look, I get it. You're working for a company that doesn't believe in upgrading stuff quickly. I mean, there's lots of those things going on. But my gosh, this is my third 64-bit laptop that I'm using, or fourth. Oh my gosh, fourth. This is my fourth 64-bit laptop. It is 2014, right? It is time to move on. The 32-bit OS is dead. It's it's served its purpose. It's done its due diligence. It's absolutely been a great soldier to us, but it's time to bury it and put it away and move on to the 64-bit machines. Please, just, upgrade. It's time. Now, your memory configuration dynamic is great. SQL Server is very cool about that, but you do want to ensure that you set a min and a max value. You want to set a minimal value because you don't want it to, after a restart, you don't want to spend a lot of time while it allocates memory. Better to slow down that restart a little bit, get the memory allocation set initially, and then not have to grow it over time dynamically. Further, you want to set a maximum value in order to prevent contention between SQL Server and the OS. So you want to make sure that that they're not fighting each other. So set a min, set a max. For calculations as to which of those, what you should set, I strongly recommend a white paper written by Jonathan Cahias. You can find his blog, you can find his information at sqlskills.com. He has an excellent thing on how to set up your memory. So it's the one place I recommend doing. Another thing you should set up, and it will affect your memory, is enable optimize for ad hoc workloads. I do consulting, and I talk to a lot of consultants. I talk to a lot of people. I work with a lot of different machines. I have yet to find a negative impact with this. I have not always found a positive impact. So I'm not telling you that this will absolutely help, but I am telling you I have found no issues where it hurts, and I have found places where it does help. So enabled, optimized for ad hoc workloads, that will help memory configurations, and it's an easy setting, nothing, no pain involved getting it set up, so it's strongly recommended. Let's move on to CPU. Please, please, please change the default value for cost threshold for parallelism. Microsoft has had this default value at 5, I think since 7.0, but it definitely goes back a long time, and it is way too low. It is ridiculously low. It's a problem. People hit parallelism on queries that really do not benefit at all from parallelism, and the problem is not parallel query execution. In fact, parallel query execution is a desirable thing for the queries that need it. The queries that don't need it just should not have it, and therefore you need to change the cost threshold for parallelism. My recommendation is for an OLTP system, an online transaction processing system, to go with 45 as a starting number, maybe even 50 as a starting number. And if there are issues where you're getting queries that you think would benefit from parallelism but they're not receiving it, then bump that down. Or you may even find a situation where you've got execution plans being generated that are costly, and you would prefer them to not get parallelism. You could bump it up even higher. For a reporting system, and a reporting system only, right? Not a system with large degrees of rights, lots and lots of contention, you may want to drop that down some, say 25, 30, and then you'll get more parallel executions on plans that could benefit from it. Again, assuming you're not looking at contention. Now the other issue is that what frequently goes on is instead of changing the cost threshold for parallelism, people change the max degree of parallelism because they have queries that are exceeding a cost of 5. So they get lots of queries that are getting parallelized, but they're not benefiting the query execution. So what people do is they set their max degree of parallelism to 1. I just cannot emphasize this enough. Instead of turning off parallelism, change the cost threshold and leave parallelism on. That way, queries that need it will receive it, and the queries that don't won't. And that's a good thing. As far as what degree of parallelism, how many CPUs and all this stuff, the best advice I can give you is go with physical and stick within a NUMA. So if your NUMA node supports 16 physical chips, then go with 16. I don't care if they're hyper-threaded to 32. Stick it at 16, stick it to physical, and stick within a NUMA. All right? That much is extremely important. Again, for details on this, I further recommend Jonathan Gaheyas. The man's got some really good stuff in discussion about how to set up SQL Server configurations. So it's a great place to go to get some good information. You can consider using the query governor to reduce CPU limit, but it is something that you will need to test, you will need to validate. Again, what you're looking for is a cost threshold on your queries, and you want to look at a particular above a particular threshold. You don't allow those queries to run, or you reduce the amount of CPU use by that query beyond that limit. This one's a little sketchy. Probably shouldn't include it in such a fundamentals checklist, but it's at least it's an option that you have available to you if you are looking at CPU load. Let's talk storage just a little bit. TempDB. It absolutely needs to be separated from other data when possible, right? I'm not saying that you can always do this, but you should try. If you have a drive that you can separate it out, you should. TempDB is absolutely, it's the receptacle for everything. I mean, people refer to it as a dumping ground or other stuff, but a lot of processing goes through there. I mean, just from as simple a thing as a sort operation within a query to index rebuilds, read committed snapshot isolation, all kinds of other stuff all go through TempDB. Large quantities of things go through TempDB. So the load there is extreme. Where possible, I strongly recommend that you break it up into multiple files. That even if it's only on a single drive, still break it up into a couple of different files, but not equal to the number of processors. That's an old misnomer. Referring back to SQL skills again, Paul Randall's got some very good information on that. Make sure that these things are of equal file size too. You want a fairly distributed thing on the files, and you want to avoid that. I strongly recommend putting on compression. At minimum, index compression, but if you can, storage compression too. Most of us, not all of us, but most of us are I/O bound more often than we are memory bound, or more often than we are CPU bound. I/O is usually the biggest deal. So if you can sacrifice some CPU and gain I/O, it is absolutely worth it. Further, using native compression, you get an added benefit of the pages will be compressed in memory. So if you are I/O and memory bound, this can help. But it will be at the sacrifice of CPU. So if you're I/O, memory, and CPU bound, it's probably time to buy a new machine, let alone try out some of these things that I'm suggesting. And frankly, more disks is better, right? The more disks you have, the better off you are, and that is just a flat-out statement. However, it is limited by the number of controllers that you have available to you. And so that's about it. That's all I wanted to talk about as far as system setups go. For query tuning, there's a lot more detail on things you can do with your systems. Again, I'm not a systems guy. I'm very much a query tuning guy, and so I'm going to keep my focus there. But there are a few things that absolutely affect query tuning on the system side, so I wanted to bring those up. Now let's talk a little bit about some administration tasks that are also going to affect your query tuning. First off is statistics. Statistics are the driving factor behind the optimizer. They are so vital. It is impossible to overemphasize the need of good, accurate, well-maintained statistics. So you should, in most cases, on most systems, have auto-create and auto-update enabled. These are must-haves. I've hit situations where they've been turned off, and it has hurt performance severely. Simply turning these back on was a massive, massive performance improvement. Yes, they are not free. There is a cost associated with creating statistics, especially if you're going to do a full scan on statistics. There is a cost associated with updating statistics, especially if you're talking large databases, multi-terabyte databases, or multi-terabyte tables, partitioned tables. There's a whole slew of things around statistics that can be painful, but because they drive the optimizer, that's a pain you need to be prepared to pay and just figure out how best to pay it. Also, you have to allow for the fact that you're going to have to do manual updates to your statistics. The auto update works extremely well. It just doesn't cover every possible permutation of everything going on. And so you're going to have to make plans for having a scanning process of your statistics on a regular basis. Further, you may need to, whoops, we skipped a button. Oh, now two came up at once. Look at that. Anyway, you may need to do a full scan on your statistics. Now with 2014, if you are partitioning, you can also try using incremental, which will allow you to update statistics per partition. I do put in there, you can try, because I want you to test this. It's not going to help everybody in every situation, but it really could. You also do need to defrag your indexes. Index fragmentation, there's a lot of discussion lately with disks being so fast. Point lookups, frequently, especially in OLTP systems, not being really hurt that much by fragmentation. There's some discussion over whether fragmentation actually matters. And I've just hit too many situations where it has helped, even in very small tables. I've seen it help performance. So I'm inclined to say yes, you should continue to defrag your indexes, but the size matters. You do need to worry about the number of pages. The recommended is that you wait until you get 1,000 pages. I think that's a little high for most people, most situations, but maybe not all. It's something, again, I want you to go back and test and validate that things work in your area. Personally, I probably would not defrag below 100 pages, but I think 1,000 might be just a little high for fragmentation. Maybe 300 to 500 would be a good max, at least to start with, and then figure out things from there. You may find a given table may need more, may need to get defragmented at 200 or even 100. I think below 100 it's an issue that just doesn't, there's even a full scan, there's just not enough not enough problems to really get benefits from it. Below 8 pages, you're looking at storage outside of a single extent, and so it'll be a mixed extent, at which point fragmentation, frequently you can't defrag. I've seen situations where you run defrag and the fragmentation gets worse, or you run defrag and the fragmentation doesn't get any better, and that's just because the mixed extent storage, which is less than eight pages, it just things act funny. So don't go below 8. You can go below 1,000, and other than that, test within the range. Probably you need to stay above 100. Now, some further administration. There are some settings that just frankly hurt, and you should avoid them unless you've got a completely and utterly valid and, again, tested reason for using these things. I would strongly advise against auto close. That's going to shut down connect after the last connection goes. It shuts down your database, and the next time you fire off a query to that database, it has to go through a restart process. That restart process is going to include loading each and every query, all your data and everything back into cache again after that database has been shut down. This is painful, long-running, really, really bad. Also, I am absolutely against auto shrink. I've just seen so many issues that this causes, contention issues, large number of files, fragmentation at the OS level. It is just a huge issue. Frankly, I've seen few, if any, good reasons for doing this. I mean, I have dealt with people who are like, well, we've only got X amount of disk, and so we shrink all the time so we can stay below that disk. And the thing is that, boy, that the answer is you need to get more disks. I mean, even if you have to just buy a USB disk and plug it in on the side of the machine, I mean, it's not the greatest solution in the world, but it'll work. At least you've got storage. And the last thing you want to be doing is constantly shrinking your databases. Also, I get it that the profiler GUI is, your bestest buddy in the world. We call it SQL TV, and you shouldn't be using that GUI on production systems. You can use it to consume data off the production systems. Sorry about the phone ringing. You can use it to consume data, but you should not plug that GUI directly in. There's a secondary buffering that it uses, and it will hurt your systems. So especially if you've got systems that are already under stress, already under load, if you're suddenly dealing with these things such that you're going to put profiler on it, you're actually going to hurt the systems. So instead, I strongly recommend you use extended events. They filter better, and they are just better in every possible way, except if you're in 2008 R2, there's no pretty GUI. So that is something, and I get it that people don't want to surrender the GUI, but by and large, profilers, extended events are a much better way to go than profiler. If you are going to use a trace, don't use profiler GUI, but use T-SQL scripts as a server-side trace. It's easy to set up. It's not that hard. You can use the GUI to configure those scripts, and then go and run them on a production system. It's harder than extended events, I think, but you do have the pretty GUI for consuming the information after you've generated it. But other than that, it's time to put profiler to bed as well. It's really, outlived its usefulness. Extended events does everything that profiler does and lots more. So it's just a better way to go. So I really do strongly recommend you go in that direction, even if you're in 2008 R2. It will mean that you've got to do some X query, XML query, because the output is in XML. But believe me, that pain is worth the savings that you're going to have on your servers. because they just will be better. All right. Now let's get into the fun stuff. Database design. It's all about how you set up your storage, the fact that you set up constraints, how you set up indexes. Databases are a fundamental part of the storage. We can't get away from these things, so let's talk about this. Absolutely, you should be separating your log and your data. Now, do you want to get into types of SANs, types of disk storage, RAID setups, all that fun stuff? Sure, you can, but fundamentally what I want to do is I want to separate the drive path to the log and the drive path to the data. Let's at least get that much done. They have different access mechanisms, they have different load mechanisms, and as long as they're running on different disks and hopefully different controllers, you'll see better performance than if they're sitting there sharing the same disk. Also, when you're setting up a database, set up multiple file groups. Even if you're on a single drive, I've seen multiple file groups help SQL Server sort of distribute the load. So even if it's going to one drive through one controller, the optimizer and the storage engine get some, well, not the optimizer, but the storage engine gets some choices on how it's going to do things, and it will help. This is not popular, and honestly, people disagree with me. And it does depend on the amount of administration that you have available. If you have a fairly dedicated administration staff, this can work. If you are an accidental, incidental, reluctant DBA, this could be problematic for you, in which case ignore me. But I do recommend turning off AutoGrow. I recognize that it's an issue for some people, but I recommend turning it off. So, but if you can't, please, please, please use the fixed growth size, but a good size fixed growth size, not 1 megabyte or 10 megabytes or something ridiculously small. Get it up there, 5 gigs, 10 gigs, 20 gigs, 50 gigs, something reasonable that's going to allow the file system to grow out on an infrequent basis without overwhelming your drives. But a percentage growth becomes more and more problematic as the database grows. So that means just whatever you do, don't leave those defaults in place. The percentage growth on the data file and the 1 megabyte growth on the log file, those defaults are problematic. It's interesting that I'm bringing up defaults that I want you to change. Most of the time in SQL Server, the defaults are good. So for example, auto create, auto update stats are on by default, and that's a great thing. And so I'm very much in favor of leaving the defaults alone until you hit issues. But things like cost threshold and certainly the growth percentages here for the files, I think that should get changed on a regular basis. Let's talk constraints. Absolutely normalize your data. Normalization is a performance enhancer. Normalization is not a performance detriment. Proper normalization is the key, though. Depending on how you normalize your data, you could introduce lots and lots and lots of joins to retrieve data. And you get up past 30 or 40 joins, and then yes, performance does begin to lag. But you're below, say, 25, 20, 15 joins. There is no reason why you cannot set up queries and your indexes and your foreign key constraints such that everything runs just fine. In fact, it runs better because you've got smaller data sets, because you've used normalization, because you've got enforced referential integrity. The optimizer can use that and use this process called simplification, where it eliminates certain tables or assumes the join criteria and is able to do different kinds of optimization. These are huge performance wins. The reduced data storage actually means more data gets stored per page. So that means, even in a scan situation where you're reading all the pages, you're going to read fewer pages or they're going to read faster. And so you definitely want to normalize. Just normalize correctly is the key. I don't think of denormalization as a good performance enhancer in most cases. Usually people denormalize where they've normalized incorrectly and they denormalize as a solution for that bad normalization. But denormalization is not in and of itself a performance enhancer. It's just a way to get around bad normalization. Make sure that your constraints are enforced. I've mentioned how foreign keys can be used by the optimizer as part of the simplification process, but only if they are enforced. There is a no-check option that you can enable, and that will tell the optimizer when it recreates a foreign key to not look at the existing data. This is faster, but it then means that that data is untrustworthy, and the optimizer will know this. It can look at the creation script for that foreign key, and it will be able to recognize that this is untrusted data, and therefore you will run into issues. So make sure that you get these things trusted. Now that does mean that when you create a foreign key on existing data, that it will have to look at that data to validate it. But if it's validated data, then it will be an enforced referential constraint, and that enforced constraint is used by the optimizer. Make sure you have primary keys. Most tables in most situations should have a primary key. Whether or not that primary key is clustered, that's a different discussion. We'll talk about clusters in a minute. But you should have a primary key. If you have alternate keys, use them. Unique values, again, are something the optimizer can recognize, and you will see performance enhancements for data that is unique. And remember that also that unique constraints are always enforced by an index. So that puts a set of statistics and an index for retrieval, so you can see massive performance enhancements right there. Also, database design, indexes. Let's just talk indexes in general, then we'll get into clustered and non-clustered indexes. Narrow. This is a scary word and a word that can get overemphasized. I would like you to make your indexes narrow, meaning better to have an integer index, than a varchar 25. Better to have a varchar 25 than an in varchar 25, right? As narrow as practicable. But that is not to say that, well, okay, only index on integers, only index on a string if it's 10 characters or less. Only, don't get down that road. As narrow as practicable. If you find that you need an index on an integer, 3 integers, an integer and a date, an integer and a date time and a varchar 25, a varchar 75, fine. But as narrow as you can and as narrow as practicable within the situation. That is your goal. Just don't be overridden by that. Don't assume that it's an absolute must-have. As narrow as possible. That's why I like to use practicable instead. Integers do index better. Why? Well, hey, let's think about it for just a second. How do machines work? They're storing numbers, right? That's what they do fundamentally. So integers can index really well. They just generally can. But other choices work fine too. So I don't want you to be stuck on the integer, but I don't want you to be scared of it either. So please look at it, but just don't. That doesn't mean that's your only choice. You need to choose your leading edge very carefully. Now I'm assuming we're talking compound indexes here. If it's a single key index, okay, whatever it is what it is. But if we're talking compound indexes, let's say you want to enter index on, and there are good reasons to do this, say a car1 field and an integer, or a bit column and a date. That's great. But I would strongly suggest that you put the most selective column first. And the reason for this is really simple. You have 3 parts of statistics. You have a header, which is some interesting information. You have a density graph, which shows you, the selectivity of the index, and that's a compound density for a compound key. And then you have the histogram, and the histogram is the primary thing used by the optimizer. It is only on the first column of the index. If your first column is a bit or a car1, then that histogram is going to be probably largely useless to the optimizer. So where possible, I would suggest making it the most selective column that is in the compound key. I'm using a lot of weasel words here. Where possible, probably most likely, right? Lots and lots of weasel words. Test, test, test. Validate that this works on your system. Given the situation, there are places where a less selective leading key is better, but there's no hard and fast rule there. But in general, you're going to benefit from the more selective column. And certainly in situations as extreme as what I said with a bit, you're definitely going to benefit from the other column being the leading edge. Covering indexes are the fastest type of indexes. They are generally smaller. They are generally, quick, good, and great. You just use the include column. That said, that does not mean that you just create a million different covering indexes. You want to be careful about the number of indexes you create, because the more indexes you create, the more load you're putting on insert, update, and delete on your system. So again, it's a balancing act. Let's see. Clustered indexes. Narrow. As narrow as practicable. Same rules apply as in the general. Personally, I think that the storage engine and the databases should be absolutely designed around the clustered index. It is the primary storage mechanism of the tables. It's either a cluster or a heap, and clusters include, the pointers to the data. They work really well, and more often than not, the cluster is the best path to your data. So that's why frequently you'll see the primary key being the cluster, but it doesn't have to be. I don't want you to get hung there either. When you do rebuild the clustered index, make sure you use drop existing. It makes a difference on how it works. And you need to avoid columns that are getting updated frequently, because every time you update a cluster key, that means all the non-clustered indexes get updated too. So that causes a pretty heavy hit on your system. So you want to avoid that. For a clustered index, it's better to have stuff that's, it's better to have things that are unique but not required. It's better to have things that are updated, very infrequently, if not at all, but again, not required. Just remember that there's a series of trade-offs. You make it a non-unique value, that means that you have to have a uniqueifier stored with the cluster. Sorry, that's how it works. If you make it an updated value, then you will be an updatable value, or one that's updated frequently, then you're going to see a lot of updates on your non-clustered indexes. Again, sorry, that's how it works. So let's focus down and talk T-SQL coding. Some general rules, easy ones, right? Old ones, really. Return the data you need, return the data when you need it. Returning lots and lots of columns that we might need, returning lots and lots of rows that, well, we're not using them today, but maybe we'll use them tomorrow. That leads to serious performance bottlenecks. You're hitting I/O, you're hitting other things that you just can't afford. So you need to focus on that. Use stored procedures or parameterized queries. Notice, I am not saying you have to use stored procedures. Parameterized queries work great. The thing is that these encourage plan reuse. The optimizer is amazing. The optimizer is great, but the optimizer slaps your CPU around pretty severe, and so you want to avoid that where possible. Also, procedures and parameterized queries take advantage of parameter sniffing, which most of the time is a good and glorious thing, something you want on your system. There is nothing wrong inherently with dynamic T-SQL, ad hoc T-SQL, but it does lead to plans not being reused, which leads to memory issues, CPU issues, and so I'm a strong advocate for using stored procedures or parameterized queries. Your ORM tools absolutely support both. There's, don't hesitate to use an ORM, because I think that they are awesome and amazing tools, but ensure that you're using them correctly. Parameterize those queries. Use stored procedures where needed. Don't feel limited that you can only use stored procedures, but whatever you do, don't throw out the baby with the bathwater. Stored procedures have incredible use. There's no reason not to put them to use, so make sure you take advantage of them. Avoid cursors, and yes, while and loops are cursors, same thing as cursors. Jeff Moden termed it, and I will reuse this forever because he gave me permission, row by agonizing row processing. It's just a bad approach. It causes issues. Yes, there are some places where cursors are probably the best thing to use. Certainly in administrative things where you're saying, well, for each database, for each table, there are certainly places where the cursors are going to be used. But most of the time, they can probably be avoided and should be. Make sure you qualify your object names. Pretty low rent stuff, but it does reduce lookup costs. It does make your code more readable, and so it's just worth doing. It's easy. Make sure that you avoid SP underscore for procedure names. Again, it adds a lookup to the master database. It's a silly little thing, but it's something you can avoid. Let's see. Avoid non-sargeable conditions. Well, what do I mean? Things like functions on columns, is date, something like that, left string, those kind of functions on a column means that it won't be able to use the statistics, and if it can't use the statistics, it's probably going to lead to scans or other bad choices in the optimizer, so try to avoid that. Like or percent anything, although it doesn't have to be percent, it's wildcard anything. Putting that leading edge, it means it has to do scans, and you want to avoid scans. You want to try, well, you want to avoid scans when they're not the optimal mechanism for retrieving data. They can be the optimal mechanism, so scans are not necessarily good, seeks are not necessarily good, neither is bad per se. Each represents a different access path to the data. I just want the right one being used, but non-sargeable conditions will lead to scans in inappropriate places. Set no count on. It just reduces round trips to the network. And whatever you do, don't nest your views, meaning a view calling a view calling a view. And joining view to view is also equally bad. What happens is the optimizer, as you take these 4 and 5 table view, so I've got like 5 or 6 tables here, and I'm going to join it to 5 or 6 tables over here, and I'm going to call 5 or 6 tables over there, which is joined to another 5 or 6 tables. Suddenly you're looking at a 30 table join that the optimizer has to walk through, and it can get timeouts. You will see timeouts, and that means that the optimizer did not optimize your query as best it could. It just optimized it best it could within the time frame that it had. And frankly, you can get really, really bad optimizations by doing this. So avoid that. Write queries. I recognize that views are attractive in that it sort of masks complex, complex join criteria and stuff, and so you don't have to do that over and over again. But frankly, T-SQL doesn't lend itself to code reuse. It is not an object-oriented programming language. It is a scripting language for retrieving data, and focus on writing it as such. Don't try to turn it into object-oriented programming. It's not. Don't use, now notice this doesn't say avoid. It says don't use optimizer hints. Most of the time you run into more problems than it's worth, especially no-lock. You want a good discussion on no-lock, I strongly recommend going to Jason Straight's blog. Look it up, Straight, S-T-R-A-T-E. He has got a great little thing on no-lock. It's worth looking through, but you want to don't use optimizer hints. There are a few places where optimizer hints are awesome. I can definitely go over those sometime with you, but the fact is most of the time people are using them inappropriately. They're trying to force the optimizer to do something that it doesn't want to do, and it doesn't want to do it for a darn good reason. So just stay away from that. Let's see, next, T-SQL. As much as you can, avoid recompiling execution plans. Again, the optimizer is great at what it does, but that's a load on the system you want to try to avoid. The best way to do this is to start with stored procedure and parameterized queries. In some instances, if you are dealing with compile issues, and these are key words I want you to catch, in some instances, if dealing with compile issues, you may find table variables work better than temp tables. Just remember, table variables have no statistics, temp tables do. Those statistics are what cause the recompile, but those statistics are good for the optimizer. So if you need statistics for the queries to come out good, table variables are something to avoid. But if you're hitting recompile issues, table variables might be something that can save you. So it's something to explore. Make sure that you use your ANSI standards on your connection settings, and do not change them within a query because that will cause recompiles. Also, don't interleave your data definition language and data manipulation language. And then other than that, adopt best practices for transactions, which means keep your scope as short as possible. It's pretty simple. That one's just not hard to explain. All right. Also use your transaction abort, and consider using read committed snapshot. And that's a great way to go to avoid issues, and also avoid the whole thing of like, oh, well, no lock is our magic turbo button. Read committed snapshot can be your magic turbo button, and in a much safer way than no lock. Let's see, T-SQL coding number 4. I'm going to be blunt and say it. Multi-statement table-valued functions are absolutely evil in every possible way. I don't know of a good reason to use these things. I don't have a valid purpose for these. Now, I'm not talking inline functions. I am talking multi-statement table-valued user-defined functions. They do not have statistics. They generate horrific execution plans. They have execution plans that you can see if you know how to look them up, but it's hidden away. You can't see them. All you'll see is a zero-cost plan or zero-cost operator inside your plan and a table scan inside your plan. And that table scan may or may not have a high cost, but those are inaccurate values, completely inaccurate, because they don't have statistics. So those things are just lies. There's no other way to put it. And my gosh, whatever you do, don't join or nest these things. You think nesting or joining views is bad, wait until you join or nest multi-statement table-valued user-defined functions. These things are bad. I used to say avoid their use, but I've just come down to the point where these are evil. All right, you can get the functionality in other places. I don't think there's any good reason to use these, and you should avoid them flat out. So here's the deal. Relax, right? It's just not that bad. A lot of things we've gone over, I mean, there's all these things, don't use this, don't touch that, be careful about this, avoid these things. The fact of the matter is most of your queries are fine. Most of your tables are fine. Most of your statistics, most of your indexes are fine. So you're okay, right? You just want to, change the things that can be changed. Work through it as you can. Again, small changes, incremental changes, monitor the systems, test, 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 right? Just make sure that you're working through it slow. It'll be all right. Help is absolutely available. You can go to hashtag SQL help if you've got really small, straightforward question on Twitter, and you will get, there's 50 people out there competing to answer your question right now. So they will give you a good, clear answer. It's fast. You can go to MSDN. You can go to Stack Exchange. You can go to SQL Server Central, Ask SQL Server Central. Any of these places, there are people sitting around waiting to give you a hand. So you've got help available. You don't have to feel like you're on your own. I'm sure I mentioned this, but I would like to reiterate, please test everything you do. The last thing you want to be doing is testing this stuff in production. You want to test it someplace prior to production. You want to validate the behavior. Ensure that what I've told you is accurate. Please don't just simply trust me. I consider myself a nice guy, but the one message I want you to get out of this is test everything, right? Just validate stuff. And please, hey, sign up for my pre-conference seminar, because we're going to go over a lot of this stuff in a lot more detail. We'll be going over a lot more T-SQL. We'll be going over a lot of execution plan stuff, and you'll be able to take this checklist and apply it with what you learn at the pre-conference seminar, at the summit. So with that, if you're still around, let's take some questions.
Wonderful, Grant. You did fantastic. We do have a lot of questions that came in. Our first one is, we have a production server with a cost threshold of parallelism set to the default value of 5. CX packets weights account for about 50% of the weights, but users have never complained about performance. Should they try that setting?
1, yes, just outright. I would change it. 2, probably you don't have any issues with parallelism. CX packet weights by themselves are not an indication of a problem. They are frequently one of the top weights that you'll see, but they are themselves not an indication that you have issues. They are simply an indication that parallelism is occurring, and that there are then weights for the context switches between the threads. That's fine. It's a normal process. It's no big deal, and the fact that CX packet weights are there is no big deal. What you want to be looking for are other CPU weights that indicate that you've got an additional load on the CPU. But no one's complained about your queries. That's great. I would still change that cost threshold for parallelism, because even though people don't complain, that doesn't mean they don't retry that query once or twice. You're right. If it's running long, I mean, I've watched people who are using the machines, and you'll see them do stuff, and you go, wait, why did you do that? Oh, well, it always breaks the first time I run it. Wait a minute, I didn't know that, right? I mean, and so you, again, I don't want to say don't trust your users. That's a bad way to put it. Your users just aren't going to always tell you everything. So trust me. Well, okay, don't trust me, but please change that cost threshold value. It really is too low. 5 is too low.
What about for earlier versions of SQL Server?
Yes, same deal.
Okay. Can you recommend any scripts to analyze your data and workload for enabling compression?
For enabling compression, not really. What you're going to be looking for is how much. I mean, it's basically your I/O, right? So you want to monitor for your I/O, seconds per write, all that kind of stuff, to understand, what the load is there, and monitor the CPU to understand how much CPU you're using, which is usually 10 to 20% in most servers. But then you can look at putting compression on and then monitor again to see how the I/O goes down and whether or not CPU goes up in an extraordinary fashion. It probably won't. I've seen like usually 1 to 2% hit max, but it does depend.
Okay. If we turn off AutoGrow on a 24/7 operational server and go the route of monitoring, when would you manually grow the files?
When needed. And by that I would say, you get down to about, say, 15 to 20% space left, you probably want to grow. I would say roughly keep around 30% available. And again, it does depend on your systems, right? So you kind of need to, before you turn that off, you might want to monitor it over time to get an understanding of, when you get surges, when you get peaks in the growth, how big are those peaks? How big are those surges, on average? And then allow for that amount, so that you're not trying to, you're not auto-grow, you're not trying to grow it after it's filled. You grow it before it's filled.
Okay. How would you determine when parameter sniffing is an issue, and how would you handle it?
Okay, well, that's a giant discussion. Parameter sniffing is, I have a 1-hour session just on parameter sniffing alone. Determining that parameter sniffing is an issue, generally you will see for a given query, same query, you will see 2 different, or maybe more, but at least 2 different execution plans. One that performs well, one that causes problems. Looking at those plans, you'll see a difference between the estimated number of rows returned and the actual number of rows returned, and whether that's high or low really depends on the plan, but you'll see differences. And those are frequently your indicators, right? Slow performance, different plans, different estimated than actual values. Those are your indicators. What to do about it? Okay, that's really, really complex, but the idea is you're either going for a generic plan or a specific plan. A generic plan, you go for things like optimize for unknown, changing parameter values to table variables, other things like that. For a specific plan, it's optimized for a particular value, or other things along those lines. I can't go into more detail next. We'll be here for another 20 minutes at least.
Okay. What do you think about index defragmentation or fragmentation on flash storage?
Yeah, same thing. I mean, flash storage is amazing, glorious, and some of the newer stuff I've seen coming out lately, especially like I saw this thing from Pure. It's just mind-numbingly fast. It's still not free, right? So scans, especially scans, right? Not point lookups, but scans have to bounce around. Even though they're bouncing around in memory, they're still bouncing around. Am I as concerned about it with flash style storage? No, but I'm still concerned about it. So I would probably still do it more or less the same way.
Okay. How many files for tempdb on a 16-core machine would you recommend to start with?
I would recommend going and looking that stuff up.
That's a good way to put it. Do you have a reference or somewhere we should look?
Like I said, Paul Randall's got a really good, I don't have the link in front of me right now, but Paul Randall's got some really good information about that on SQLskills.com.
Perfect. Is it okay to use extended events in production?
Yes, but filter them. Extended events filter differently than trace. They filter better than trace. So you filter the extended events, say go for, I only want to observe this database, or I only want to observe this user, or I only want to observe this store procedure, and then it will only capture those events, and you won't, the load will be very low. So it's very safe. It's a great way to monitor production.
Okay. For table partitioning, any advantage with splitting it to multiple file groups?
Yes and no. The thing about table partitioning is people tend to look at that as a performance enhancer, and more often than not, it is not a performance enhancer. It is meant to enhance data management, and it does a great job in enhancing data management, but usually at the cost of performance. I would be very loath to suggest partitioning as a performance enhancer. It makes me very nervous. If you've got large-scale data, you're having to deal with like the whole moving window style data, retrieval and archiving and all that stuff. That's what partitioning is for. If you're looking at, I'm hitting I/O issues, partitioning most of the time is not going to help you. There are places where it can. You can set it up very carefully so that it will, but that's rare, and so I would avoid it. But are file groups the way to go? Yes. Further, different machines, different disks are the way to go. Split it up, partition views across multiple servers. Huge, huge, huge win, assuming you don't end up doing scans across those things. As soon as you start doing that, performance is worse than it would be if it was local.
Okay. As a follow-up to that, what does the difference make if you don't have multiple file groups on a single drive? Like if you...
It just gives it means that there are fewer access paths to the data, and so the engine just has fewer choices, and so it's single threading things, right, effectively.
Okay. Given a server with a certain number gigabytes of RAM, what is the criteria or percentage to set the minimum and maximum for SQL Server?
Right. Again, Jonathan Cahellas, SQLskills.com. He's got a great little formula for it. I'm not even going to presume to steal his thunder and reiterate it here. That would be the place to go look that up.
Okay, perfect. When you said the clustered index should be narrow, why should it be narrow? The amount of data is the same, and more columns equals more functionality.
Well, the amount of data is not the same. Because what we're talking about is not simply the amount of data stored at the leaf level, in which case you're right, it is all the same. It is all the intervening levels, the top of the key and each branch of the balanced tree in which the clustered index is stored. Each one of those stores some number of values, and the wider the key, the fewer values those can store, and then a deeper and or wider index is created. So you want to try to avoid that. You want to read as few pages as possible when you're doing these things, and the way to do that is keep the index as narrow as is practicable, right? Again, I'm not saying only, I am not one of those advocates of the, one true column to rule us all, right? It is, you can have 2, 3, 5 column indexes. That's okay, but caution, careful, studied, tested approach to ensure that that you really do need 5 columns, that there's not a better way to go.
Okay. I think we have time for just one more.
Cool.
We use 3 SAN volumes for our DB server, data, tlog, tempdb. Since these are all on the SAN, is this still considered having tempdb moved away from the database files?
Yes and no. You need to be buddies with your SAN admins. You need to go and talk to them and ensure that you're not, again, a SAN can be configured in a very, SANs can be configured very well, and each of those LUNs or drives is completely separated from the others. You're not worrying about sharing all the controllers. You're not worrying about sharing the disks, and that's great. But they can also configure it so that even though you've got 3 different shares available, they're all on the same drive, or they're all on the same set of drives. They're all going through the same controller. So, again, I'm not saying that your SAN admin is bad, but you should talk to them. You should work through things with them, validate what they've done, and ensure that you're looking at some good stuff. But that just means talking to your SAN admin, because there's no way for you to know from your end that you're stepping on yourself. So you have to talk to those guys.
Perfect. I think we should probably wrap up now. So can you
Okay,
flip to the next slide for us?
sure.
Perfect. Like what you heard here, Grant will be presenting at Past Summit 2014. Catch Grant in his general session, Getting Started Reading Execution Plans. It's a fantastic session. And the full presentation of this pre-conference, Query Performance Tuning in SQL Server 2014 at Past Summit 2014. Don't forget to use the code 24HOP14 to save $200 on the Past Summit registration. Stay tuned for our next session, Are Your Indexes Hurting or Helping You? With Jez
And,
Borland,
and
happening in a
that's a good
couple of
session.
minutes. Yes, it is.